To get started, oh, is this it? All right, cool. I think I might be live. Hello, this is my first stream, so go easy on me. I'd like to talk about the code base for Scream. So, hi, I'm Trey. I run the business Acoustics. I'm the dude who wrote the code for Scream Filter, the vast majority of it anyway. Yeah, we're going to walk through some of the code. Let's just see what's on the agenda. We're going to talk about the algorithm itself. If you know roughly what the algorithm looks like, then you might be able to recreate this yourself inside other doors. And by chaining a bunch of plugins together in a clever way. If you also sort of know what it does to the sound, then you might be able to recreate it in other ways, like FM. So we're going to be talking about how to do that. And what else we got? We're going to go look through the white paper, get nerdy for 2 seconds, ways in which I get a good sound out of it, how to tune parameters good, and then much more nerdy code related stuff, which I might have to put chapters into this stream, so that different people can find what it is that they want to know. So Scream's made with a custom framework, one that I just wrote from scratch. So I'm going to talk about that. Also how to build a plugin. Nice tools like hot reloading, hot plugging, which can be a little bit tricky on Windows. We're going to talk about that. GPU rendering. That's becoming more common these days. I can show you how I think, done it to pretty good success. And immediate mode GUIs. I'll explain what that means when we get to it. All right. So the Scream filter itself. Now, there's a really popular paper published by one of the staff members from Native Instruments. His name's Vadim Zavalishin. Paper's called Art of VA Filter Design. If you just Google that, the Art of VA Filter Design, it's like first result. That's just the one I've clicked on. So he talks about how to make filters. Well, the thing I'm most interested in is how to make filters that can be modulated really fast without blowing up. That's some technical stuff that we're not going to get into. I think hints at how to make the Scream filter are left in Chapter 6, Nonlinearities. So if we just check out one of these block diagrams that he's got here, oh, maybe I've gone past it. No, maybe I didn't go down far enough. Yeah, here's a neat little block diagram, this is roughly what the Scream filter looks like. It's not, looks like a ladder filter there. We're not doing that. We've kind of just got like a high pass mixed in there. I think it's page like 233. He starts talking about getting a bit creative and like just like adding different filters into the chain, and sort of who cares about latency, but does it sound good? And that's exactly what's going on. That's exactly what we're doing here. So I'll pull up some code. Where is it? Process audio. So, all right, so we've got a few parameters here that we tune. Ultimately, like you've got a low pass filter, a high pass filter, and some distortions. Those distortions will have some amount of input gain, and we cleverly use feedback to like really amp up like the gain that's going through the low pass again, and through more distortions, and so on and so on. let's just find the magic. Resonance. So they're 2-pole filters with resonance. You know what, maybe it would help if I actually just launched the plugin. Okay, so for the nerds, X, that is our input signal. We're processing audio here sample by sample. This is the last sample feedback that's coming in. It's getting distorted. So we're summing the feedback signal and the input signal, throwing that through a distortion. So some feedback and input, distort, low pass, applying mixing there, and yeah, that goes to the output. So feedback, distort, low pass, output. Then we need to get fancy with the feedback. So the feedback first goes through a high pass, then it goes through a distortion again. And here we're doing some tricks to try and stop self-oscillation. Since the signal's just distorted so much, there's so much gain that's been driven into it. You need, I think we're doing clever ways. Yeah, feedback gate detected by input. Where have we got X here? Yeah, okay, so there's our input signal. And yeah, if the input signal's quiet enough, then we just decide, it's probably time to just like drastically reduce this feedback gain so you're not getting this nasty ringing sound. I could try turning that off just to see. I can actually create the problem by turning this off. Is that going to compile? Doesn't like the fact that the program's running. It does compile. Yeah, there we go. There's the self-oscillation problem because I've turned off that gate. So, yeah. Rickster from Cure Audio was helpful actually in making this, and yeah, required a fair bit of fine-tuning. But yep, that one works pretty well. What else we got? No, I think that's mainly it. Thing is, there's actually more parameters going on under the hood than what we show here. So the trick with this cutoff, like this cutoff's not only moving a low pass, but it's also tracked to the internal high pass, which is filtering that feedback. And Scream is controlling literally just the high pass cutoff. So like the higher that the Scream filter is, the higher the cutoff is. And at some point you just like don't even get any distorted sound because it's just all being filtered out, right? You start turning it down, and it's like it's accentuating the highs. So that's pretty cool. And it's just more expressive. Like if you have the cutoff not only moving the low pass but also the high pass, it does mean that there's like a bit of like surfing between the two parameters. But man, you just get a better, I suppose, user experience if the low pass and the high pass are both controlled by a single parameter. It's like everything just feels like it's in tune, which is nice. And if you play with the screen filter in some other synths which will have a screen filter, you don't get that like sync between the two. You can do it if you're just like careful enough with how you tune the parameters. But it's just nicer to have less parameters and to have things automatically synced. I'm talking about Serum Screen Filter. In some sense, you get more control, with that one, and you can still get a pretty good sound out of it, but it's just a little bit more work, my opinion. All right, so that's roughly the idea behind the filter. Oh, yeah, how I use it. So, Scream's got these like MIDI key tracking capabilities mixed into it. It can be a little bit tricky to sync up in your DAW because you need to route MIDI to it. Bitwig's pretty good at that. So if you're a Bitwig user, then you're in luck. Because since that output MIDI, like Ghost does that, Serum will do that, Vital will do that. I think Serum does that. Surge certainly does that. Bitwig is pretty good at just routing that MIDI information to other plugins that are in the chain. So let's just load up some plugin here. And we've got Cure Audio. So that actually makes, the MIDI key tracking makes it really useful for acid sounds. And if you do one shots, I reckon you get a better tone. If you were to compare that to, let's just turn that off and get like a plain old boring low pass. We'll pluck this. Then put a distortion on it. Like, if you compare that tone to when I put the screen filter on it, it's got like way more character because the distortion's sort of mixed in with this feedback network, and the feedback itself is getting filtered in this interesting way. So yeah, I think that adds, it creates a bit of a different tone. Yeah, I think it's way more musical. And if I put, where's mini meters, this thing? If you look sort of roughly where this cutoff is, you can see like there's more peaks and stuff. Like you can see this cutoff moving around here, the high pass. There's just like all these extra little notches and peaks that are in the frequency spectrum, which I think give it a great musical character. And it's all like the placement of these peaks and notches, they're all linearly spaced, like it's kind of like a comb filter. So it feels really harmonic and natural, and you just wouldn't quite get that same tone out of just like a low pass going into a distortion. So having you know, filters designed to sound this way, I think sound pretty good. All right, yeah, how I use it. I find that the lower, like if you're playing more like bass notes, I think a good habit to get into is to have Scream around 50%. That's the high pass. If I start going like you know, too low or too high, it just sounds like butt. So like 50% for like sub bass, and then if you're doing more acid sounds or you want to make some sort of lead, again, like I think low is always bad. Anywhere from like 50 to 100, I think is pretty good. And all of a sudden, I think the resonance knob is optional. Like if I go back to play bass again. Can you hear that? It just sounds like muddy and flabby and not great. Like maybe you can find a good source where like a lower resonance sounds good on a bass, but I think bass, scream close to 50%, maybe slightly less, maybe slightly more. Resonance fairly high. And then like if you want to put it on a lead, I think it sounds better. You can actually put resonance as loud or as quiet as you want. And I think the high pass sounds a lot better when it's much higher. When the high pass is higher, it's the position of the cutoff of the high pass is closer to the low pass, and I think it just adds a lot of nice notches, like around where the low pass cutoff is. I'm getting a bit slow with my musical jargon. So, can you hear that difference? Like it's subtle, but it just gives a plain old saw wave, like a fairly boring saw wave, right? Like more of a musical tone. So, but yeah, like if you're playing bass notes, scream. If that's too high, then it just doesn't sound good. All right, back to the agenda. So yeah, I think we've done that. I'll just delete that. Our tuning of parameters. Yeah, let's go back to nerdy code stuff. Yeah, sure, whatever. So yeah, it took a little bit of min-maxing to find something that sounded really good. What have we got? Like if you're a programmer that's ever written a low pass filter before, okay, we're not really using any the low pass filter is a plain old Butterworth filter. We're using a little bit of resonance on the high pass filter, so that when you start really driving that resonance, that's boosting not just the gain for distortion, but also the resonance on the high pass filter, so that this is some annoying thing that's happening while I'm streaming. It just gives the that peak enough of a boost to it. You can't, because it's tied in with the whole feedback network, if you put that resonance too high, then it just starts squealing like mad. Same with if you make the gain too high, then it can just be like really flabby. Yes, another interesting thing, this auto gain. So if I turn this off for a second, let's show you how bad this sounds without the auto gain. There's a certain Goldilocks zone. If you pay attention to this input here, the closer it is to this line, the better. I don't exactly know why this is, but it's very important. If it's too low, then you just get this awful like ringing sound. And if it's driven too hard, this input, then it just sounds like flabby and bad. For some reason, the Goldilocks zone is close to zero. So, like, while we were making this and getting beta testers to play with it, they'd slap it on. We'd tell them to use to like surf the input gain um, such that they could get like the sort of intended sound, and even like make it slightly louder, slightly softer, such that they can get different distorted tones out of it. Maybe we thought, oh, that could be like a bit of a feature, um, but no, users never listen to our advice, and so we just one day I had this idea of how to make a simple auto gain to stick on it. I made it on by default, and then suddenly all the complaints, all of the criticisms that beta testers had, like, oh no, this doesn't sound anything like the screen filter. You know, what on earth are you guys doing? Um, all of those criticisms stopped because now the sound like we were able to give users the sound that they wanted by default um, with this simple trick. And from videos I've seen of other people use this thing, no one ever talks about the auto gain. um, no one ever seems to turn it off. Everyone leaves it on, which, yeah, maybe it should be. It's kind of too complicated. Um, but yeah, if you do want to get these subtly different tones, try turning the auto gain off, and yeah, good luck finding that Goldie. I mean, use your ears, you'll find it. But it's just a bit of a pain in the neck um, to constantly uh, surf the input. And you know what? Software should uh, make making music easy. So anyway, yeah, that's why we've got an audio gain. What other features does Scream have? Anything else worth talking about in here? No, I think that's it. Cool. All right. On to, all right, done that one. Custom framework. Yeah. So there's a couple of really popular frameworks. That would be probably Juice framework number one. Steinberg have their VST GUI system. There's also iPlug, a little less popular, but it's still pretty good. Still, you know, a number of people using it. And then DPF, I barely know anyone using that one, but it's got a bit of popularity in the Linux world. I think it's pretty underrated. I think there's some nice. I can say a lot of nice things about it. I'm not sure if they support audio units, but yeah, we're not using any of that. I built much of this framework from scratch. That's how I do all of my plugins. That's how I'm doing upcoming plugins that I'm making. And so why do it? Well, I had some pretty bad experience using the Juice framework. You know, if you're a new plugin developer and you're looking for tutorials on how to make plugins, you don't know where to start. Most people will point you towards the Juice framework. I think it might be the most beginner friendly, or at least just that's where the tutorials are. And by virtue of having tutorials, that makes it good for beginners. But it's like a close to 1 million line, like behemoth framework library. And it's all written in fairly modern C++, or not super modern, but modern enough to make compile times really, really slow. It's got a highly opinionated build system, which at least in VS Code is just like constantly breaking. And you just end up in all of these like long compile time cycles where you know, if you, at least on my computer. Things like Juiceaid are constantly rebuilding. From what I hear, even other people, I think some people even using CLine, which has their own little variant of CMake. I think Juiceaid constantly recompiling all the time, taking seconds out of their build times, which is enough to um, lose focus on whatever you're trying to do. It's enough time to pull out your phone and start scrolling social media. In which case, compile times might take 10 minutes since you just waste time on your phone or some nonsense like that. Um, yeah, it's unacceptably slow and cumbersome and difficult to change because it's so opinionated in how it wants to be used. And it doesn't have certain features that I want, such as GPU rendering, something we're going to talk about today. Um, so yeah, I went and made my own GUI wrapper where it's just like this one nice module. All it does is wraps a plugin, and I don't know if this was the best idea, but I also built hot reloading into the standalone build. If I was to do this all again today, I might make a few different decisions. This is something I made a couple of years ago, where, all right, so yeah, if you've been watching this stream, on your second monitor or something like that, from here on out, this is all just going to be nerdy code stuff. So yeah, rough anatomy of a plugin. When a door loads your plugin, you're going to have the the door is going to call some function to initialize anything broadly that your plugin might need. Not necessarily an instance of your plugin, but just to set up any maybe global data that you might have. It's going to call some sort of load function, and then when it's completely done, there's no more instances of your plugin left. It'll call an unload. Your door will be creating and destroying the plugin. It'll want to know the number of buses, or like you shouldn't really say channels because you could be confusing like an audio track. Um, I guess you could say the door wants to know how many um, yeah, how many tracks or buses that your plugin wants to take. So usually plugins will only have one stereo input, but they also might have two stereo inputs in the case of sidechaining. That's just one example. But for whatever reason, maybe they've got more. And then, yeah, how many channels does this bus have? You can set a name for it so it can have a pretty name for it inside the door. If you have, for example, a convolution reverb, maybe your your plugin's got latency, and then maybe it's also got a tail on it. Your door might want to know that for optimization reasons, knowing when and when not to ping your door to try and ping your plugin with new audio data. So it can try and save on CPU. Set sample rate and block size. This is just a simple dumbed down wrapper. It's like a skeleton. It'll pass you some audio here. It's going to want to know a whole bunch of parameter information. If you've ever made a plugin before, you've filled in all of this boring data before. Load and save state. So when people save projects, you save your state and you load it with all of your parameter info and whatnot. Some GUI stuff. You want to be able to attach it to the parent. VST doesn't have the ability to hide a plugin. I'm pretty sure audio units do, but I don't think anyone really uses set visible false. Clap does, maybe. Bitwig has the ability to set your window to not visible. Um, I might delete that. I don't like it. Oh yeah. So that's for Windows. Quirk of Windows is, maybe I should actually write a comment here. Windows only. That's like if someone goes into their display settings on Windows. I don't know, display, and they want to like zoom in text. The parent window gets notified with that information, and the child window doesn't, which is going to be your window. So it's built into plugin specs like VST3, like Clap audio unit is Mac only, so it doesn't have this, of course. But yeah, it's built into there to relay that information to a plugin. Get size. So when you start resizing, or when you open up a new window, the door is going to ask you like, how big do you want this window? And it will, when you're resizing, maybe you've got some clever algorithm to maintain the aspect ratio while you're resizing. The door's going to quickly check with you, oh, do we like this size or not? And then in the case of Scream doing things like this, you can have your plugin tell the host, the door, who owns the parent window, please resize this new shape. You get other plugins like I think Vital, if I got that on here. I think they might have some way to like say, oh, can you make this? Oh yeah. So, oh, is that a bug? What's going on? Anyway, maybe I'm just a noob. Um, uh, yeah. So some plugins will just have a convenience thing um, for like resizing, because you get some doors like Reaper where I don't know why it is, but trying to resize a window in a really pretty way in Reaper is just basically impossible. So that's just what the skeleton of a plugin looks like, and that's all. Um, you know, a plugin wrapper should be. Um, uh, anyway, none of this matters. It's just a whole bunch of nonsense code trying to like dumb down everything VST3 wants to try and do to something that plugin developers actually want to use. Um, so that's the idea of cplug. Where's my agenda? What else do I need to talk about? Talked about the benefits. Actually, yeah, okay. I've roughly talked about that. Let's talk a little bit more about benefits. So we've got add features you want. Yeah, I mean, so I think it's built into like the definition of framework that like it wants to control how you do everything. Like one of the biggest motivations for the real deal breaker for me was Juice not having a great way to do GPU rendering. And then I suppose a secondary one was the really bad compile times. So, like, if people just took a drastically different approach to making software and making plugins, then maybe it wouldn't be such a bloody pain in the neck to actually just change your rendering stack to something that does what you want, or to change the way that you write interfaces from using one library to the next. If things were a little bit more modular, then I, I I think a lot of plugin developers would be a lot happier. And yeah, part of the point of cplug was it just solves one problem. It just wants to wrap um, your your plugin into something that developers can use. Um, whereas, and then you can pair it with like like whatever framework that you want. If you wanted to write your own GUI framework, then you could use that. If you wanted to pair it with like the Qt framework, you could use that if that's how you like writing GUIs, or if you work with other people who all know how to use that, you can use that. WX widgets, yep, why not? I'm sure you can do that. Visage, that's a fancy new thing that some audio developers like. Well, you can do that. Web views, I think you'll have an easy time pairing Cplug with web views. So that's the whole point. Whereas all of these other all of these other frameworks, like they all need to, because they've got such opinionated ways of doing every last thing. Um, like they've all got their own little web view module, and if you want to try and use the Qt library instead, because maybe you've got your reasons. Well, good luck. Like these frameworks are only working against you when you want to try and do this thing. So big pain in the neck, and you know, for a plugin for software that's as simple as like a window, there's a few parameters. There's a few things on the screen that you can click on, and it just makes a noise. It's got some audio coming into it, and it does some processing to it, and it sends it out. Like it's not incredibly complicated software. At the end of the day, it's not like a video game. It shouldn't be this hard, but frameworks make it really hard to do all sorts of things that you might want to do that don't follow the playbook of what the frameworks already had in mind for you. And it's a bit of a shame when they're decades old, and it's got a whole bunch of legacy design ideas in it that don't play well with how people want to do things today, such as having things rendered on the GPU, having really good performance of all these fancy animations that you might want. So yeah, those are some of the real big benefits to having a custom framework. Yeah, and the cost of changing, let's say, one GUI system to another, or one other little aspect of your own custom framework, the cost of switching from one way to do um, one way of doing things to another is much smaller, because you're not taking you're not replacing an entire framework with um, another framework. You're just changing one module, which is a much smaller cost. Like you've got a smaller cost to changing these things. Maybe you've got some fancy way that you want to load and save state. That's it doesn't take too much code to rewrite that. Whereas if it's deeply tied to all of these other things that's going on in your framework, then yeah, it can be a real pain. Hot reloading. Yeah, let's talk about hot reloading. So Cplug, Windows. All right. So cool trick when you're working on plugins. It's really nice. Let's say you wanted to change the color of something in your plugin. Oh, this is not it set to hot reloading right now. Doesn't work in release mode. All right, let's say you wanted to do something like make the font bigger. Let's say hypothetically this text was too hard to read, and like here you are, you're in the zone. building out features of your GUI, and maybe you're working with some design, and the design has one thing, um, like it might have the text looking, a certain way with this font. It might be of a certain font weight, might be of a certain color and size, and it's just not working for you. Um, like something about it just looks wrong. Maybe it's something to do with a renderer, or what. And you've got this great idea to quickly check, um, to see if maybe it would be better if you used a different font size. So where am I? I think it's like label size. Param scale 24. Oh, is this hard coded? You know what? Okay. So here's the title. Let's say you just wanted to make it a touch bigger. Oh, that's way too big. All right, my bad. Smaller, smaller. I think that's what it was. Okay, that's a little bit bigger. You just want to find that sweet spot. I think that's too big. I mean, it should be this size. But it's much nicer if you can have everything running. You can still play with everything, and like your plugin just reloads after changing a value. All I'm doing here is changing a value, hitting Control S, save, and then if I look in here, this debug console, I don't know what that is. This is an error. What on earth? Oh, this is something I'm testing. All right, well, I'll turn that off. All right, yeah, there's a bunch of stuff I'm actually still working on. So yeah, that's nice. But how do you do it? Let's look at what it takes to do hot reloading. Hot reload. Is there a way I can watch directory? If not def. Sometimes some of these programming tools can just be a bit of a pain. All right, let's go full screen. Let's talk about how to do hot reloading. Okay, it starts by, you want to be able to scan for file changes. Where have I got that? In Windows. MIDI stuff, audio stuff, MIDI stuff, menus. Yeah, here we go. All right, so there's, I mean, different operating systems will have different ways of doing this, but here's just like some function on Windows where you can pass it a directory. So here we create like some, I suppose, ID for that directory or a handle, which we pass to some other operating system function, and we periodically peek. We periodically poll for changes to see if there's any changes to a file, if we find that a file is modified. Here, here we've just got this this file change message that we're printing to the console. So maybe if I change, if I modify this, so the modify time, because I've hit save, is changed, that gets triggered, and then in the console here, we should be able to find that message being printed to the console. Yeah, file changed at some time, some value in nanoseconds. It's got the name of the file, GUI.c. Where is it? I don't know how to hide this stuff. This is just nonsense that happens in VS Code's terminal. It's a pain in the neck, but I don't feel like writing my own text editor or my own plugins for my own extensions for VS Code. This is sort of like good enough. All right, so you've got some notification event. Now, what you want to do is, do I turn off the audio here? So you can safely, like on the main thread, you shut down the interface, you stop the audio. I think MIDI, because that's happening on another thread. It's fine if MIDI events just like queue up on that other thread, but audio you want to gracefully stop. You save the state of the plugin, you destroy it. And because plugins are all DLLs, like this standalone version, it's just treating this plugin as a DLL. It can just load the plugin, and it can also unload it. So when we detect a file change, we just shut everything down, unload it. In this particular build setup, I've got a build command that I can actually just run. So what we do is we create like a different process that runs the build command. Can we see it in the not with Clang D? If we look at this, here's a macro that I set up. It just says cmake build thing at that location, to that location, debug mode, and that's the target, the cmake target. But it doesn't need to necessarily be cmake. It could be just triggering a build script that you've got, but it's just a macro. It knows how to do that. So that either runs or not. Let's say I write some invalid code and I save it. I get a compilation error, but hey, look, my window's still running. So I fixed this compilation error. Bam. Now it's all back. So I've got in here some way to like gracefully just like not start up the audio and all that again, and just like wait for like a successful build. So I think I've got wait, do I want to do that? Oh yeah, here we go. I checked the exit code. So if the build fails, then the exit code won't be 0, which is like an unsuccess. That means it's like returning an error. Warning, build failed. So, I do that again, foobar. And I should get like a, warning, build failed, exited with code 1, perfect. And now it's successful. So great, if it's successful, then we load the plugin again. We set the state that we saved. This is all cached. We restart the audio. We open up the GUI. We've, I believe, because the size of the window well, we're assuming hasn't changed between these builds, but we just look at the size of the window and just pass that straight to the plugin, and it should just be the same size as it was before. Set all that stuff up, and bam, because the state's been restored. Um, then we can just do all this again. So in this load plugin, this is where we just like load the DLL again. We load up like a vtable of all of those cplug functions that we needed. This is all ugly, but it's just, repetitive. It's all just doing the same thing. Loading a bunch of functions, bam, and we're good to go. So that's all hot reloading is. It's you've like people. A lot of frameworks don't do this. They should either do it out of the box or offer some sort of easy way for you to do it. I've seen. I saw this one guy, Jatin Chowdhury. Uh, I saw he made like some public repo on GitHub for a while. I think it's hidden now, or maybe there was some reason to hide it. Maybe it didn't work. But I remember flicking through his code, and I think because it's fairly tricky to try and do with Juice. What he did is he launched a new process, and then found like the part of like the Juice framework where they create a standalone application, and within that, um, like that, the other process just runs that. Meanwhile, the main process, that's the thing doing the scanning for file changes, and the like loading and unloading of, well, I don't even think it's doing. Okay, so the process is the one doing the unloading. The the main process, what that does, it sees a file change, it kills the process, it rebuilds the plugin, and then it launches a new process, which will call like Juice standalone build run. So um, it's kind of like looking at the uh, the root of the whole standalone build. It's just launching that. I'm sure you could do something similar with iPlug if iPlug doesn't already have a way of doing that. There's probably a way of doing that with standalone builds coming from like VST GUI, people using Steinberg's VST3 SDK. There's probably ways to do it with like the clap wrapper thing. They've got standalone builds, probably DPF as well. If you just like find whatever route. But yeah, useful trick. Your options are, you're already writing a plugin. You could just treat your whole application like a plugin, which is what cplug is doing. Um, um, and you get the benefit of having like the window all sort of like already set up, ready to go. Or you could just launch the whole application in a new process, which it might be marginally slower, but at least you still get that nice turnaround. And you can avoid switching to a web view, which is what most people do these days if they want incremental builds, because like for some reason they just don't use this trick, which honestly you could get like an LLM to do these days. It's just like a few operating system specific calls that you need to know and use. An LLM would probably do a really good job. An old model from 2 years ago would probably do a good job of writing that code. So yeah, no reason not to use it. The faster your build times are, the more beneficial it'll be. Like if your build times are like, if you've got incremental builds that are like 3 seconds, then you might just be screwed. But if your incremental builds are like half a second or less, I mean, there's more stuff going on there than just building, and it's happening in a fairly awful way. But it still only takes half a second, and that's pretty good for me at least. Fast enough for me to not really think that I need to go use a web view to just get like a better developer experience. And of course, like using a web view is going to come with other costs, like how do you move data from C++ land to JavaScript? Right? Like that's just a different can of worms, and you're back in the JavaScript, CSS, HTML files all being different, all requiring different windows, like just constant context switching, nightmare. Um, it's not exactly a win moving to that. Uh, anyway, uh, what else do we want to talk about? Hot plugging on Windows. Yeah, there's a cool thing I found. So if you're a Windows nerd, maybe you didn't know about this cool thing that I do with MIDI, hot plugging. Um, so end MIDI in. Cool. Connect input. Port number. MIDI caps. So, if you're working with MIDI inputs on Windows, there's is this the one? MIDI caps. Last connected input. Maybe I can't talk about this because it's been like 2 years since I've talked about it. MIDI caps 2? Yeah. I swear it was like in MIDI caps 2. Have I got that? You know what? We're going to skip that one. Because I think I've forgotten how it works. Oh well. GPU rendering. Cool. Let's talk about the GUI. So, nice brag. Let's just put this on release mode. Look at how fast I made the main thread of this immediate mode GUI interface. Look at this. Frame time. Wait, is this really release mode? Well, maybe that's as good as it is when streaming. Just take my word for it. When I'm not streaming, this number, this frame time, right now it's looking like it's close to 100 microseconds, like just shy of 100. When the computer's not under so much load, it's around 50 microseconds, which is nice. It's a nice brag. Realistically, in a busy door, yeah, maybe 100 microseconds is more likely. That's pretty nice for a synthesizer. If we look at what's taking up all of the CPU on my system, where's Scream? It can be a little bit hard to find it. There we go. Let's select it there. Maybe it's not a great big brag, but like, Windows Explorer regularly uses more CPU than Scream does. Whatever is going on in system, Windows audio device graph isolation. That's probably some stuff with OBS. Like it's not rating particularly high on the list of things that's consuming CPU on here. So that's pretty nice. Meanwhile, I'm rendering all of this stuff every frame. Every frame I'm sending to the GPU. Coordinates for all of these, all of this text. I'm doing text layout constantly on the fly. It's not cached. Constantly just recalculating text layout of all of these items. I'm calculating this cute little trail that you see on the screen. And yeah, calculating like how are things modulated, calculating like the decay of this peak, like all of this stuff happening on the CPU well under 1 millisecond. And so like if your monitor's at 60 hertz or whatever, but if this was completely uncapped, I've got this neat little metric here, it could be close to 10K or something like that, potential frames per second. So yeah, really, really efficient. How did I do that? Well, here's a graphics library I've been chipping away at for quite a while. let's look at the design. Actually, let's start by by looking at the shaders. So, here's one for GPU nerds. Inigo, Keyless. This is 2D things. If you've followed a couple of tutorials on 2D graphics before with OpenGL or whatever else, you've probably come across this guy, Inigo Keyless. He's got a bunch of simple algorithms for different shapes. And ultimately, oops, wrong button. Ultimately, an interface is mostly just simple shapes. If you look at that, that is like an SDF line. I got line on here, 4 lines. It's literally just that algorithm right there. For that tick, that's a circle. Another circle, that's an arc here. All these little dots here, I actually just wrote my own SDF to make that shape. That's a triangle, that's an equilateral triangle. That's from here. That's a rounded rectangle. That's another rounded rectangle, like the background, this sort of curved thing that is on this button. Like most of what an interface is SDFs. Oh, like if you zoom in, if you look at that, let's try zooming in here. Like there's this nice little detail of like a little bit of white here, and maybe it doesn't really come through, but I think there's also like a bit of black up here, and that's to give I guess some sort of like fake lighting effects. It's to give it like fake depth, but it's literally just like drawing 3 circles. So 3, 6, 9, 12, 15. I'm sending all this data to the GPU like 60 times a second. And how can I do that so fast? Well, after doing a whole bunch of profiling, what I found was the thing that was taking up all the CPU time when trying to do GPU rendered graphics is, I think for the most part, draw calls. Whatever you can do to reduce the amount of draw calls, even on modern GPUs, which are supposed to be really optimized for like being able to handle dozens and dozens of draw calls. Still, the overhead of making so many damn draw calls adds up really fast. So the larger the batches you can do, the better. So I wrote a special shader where all of these shapes, what I do is I pack all of this data into like a struct, which I unpack on the vertex shader. So here's some coordinates. There's a little to do here. This is all like a work in progress. I probably actually don't want to compress that to an N16. So here there's like a rectangle. This is 4 values. No, this is 5 values, I think. Yeah, this is 5 values packed into one 32-bit integer that I just unpack in the shader. This is a technique called vertex pulling. It's been around for maybe 10 years or so now. So like at this point, old hardware supports it. Really old hardware supports it. And by packing data this way, you can also reduce the amount of bandwidth. Like the amount of data that the CPU sends to the GPU is greatly reduced. So that's another big gain. That might be like the second biggest gain as far as reducing GPU usage. But yeah, number one would just be reducing the amount of draw calls. We've got a the important things to look at would be texture ID, SDF type, gradient type. Let's take a quick look at what these types actually are. So I've got like an enum value for a whole bunch of different shapes. Is it a rectangle, fill, circle, fill, triangle, filled or stroked, arc? Is it like a pie shape? Oh, do I have any pies on here? No. Okay, so that would be an arc there. Maybe this one doesn't use pies. It uses lines. Yeah, it uses rectangles, circles, all of that. And if I look at where I'm checking for this, you can see I'm using the roundbox algorithm from SD roundbox. There we go. Where certain rounded corners are optional. So, wait. So that's a round box right there, I think. And the corners are optional, so there's no corners in the bottom. Um, and yeah, this lets me, like in one draw call, draw shapes for all these different things. And as I'm building up this big queue of work for the GPU to do, like all these different shapes, they've just got like a slightly different enum value, and I pack the data in all sorts of fancy ways. So here's something I don't see too many people do. Certainly when they're trying to educate people about um, writing shaders, but from what I read, like plenty of people who are writing game engines, like they all do this stuff all the time, like packing and unpacking data, because they care about bandwidth quite a lot. Um, uh, if we just take a quick look at this, unpack unorm. So it's a way to take, come on, page load. It's a way to get like a regular unsigned integer and turn it into a vec2. And there's also like a 4 by 8, and that'll turn it into a vec4. Sometimes, in the case of the signed integers, you'll get a result between -1 and 1. In the case of the unsigned integers, you'll get values between 0 and 1. And like when you're moving values around in this way, you can reduce the resolution a little bit of whatever value it is that you're trying to pass in, but maybe the range doesn't matter so much. So for example, a stroke width, like you'll probably never want a stroke width of 1000, right? When you're drawing like stroked rectangles, it honestly might cap out at 20. And you'll probably never in your life write an interface where you're stroking a rectangle with like a width of 20. Really, you'll probably cap out at 4 pixels. And in the case of like Mac OS, where things might be multi-sample anti-alias, that would be like 8 pixels. So here, I think I'm looking at the pixel shader here. Here, just a fancy thing that GPUs will do. People will get told things like, don't write conditional statements inside GPUs because all of these, like the single instruction multiple thread model of GPUs, will get messed up if you start having branches, and that can like slow things down a bit. But if the condition can be like resolved because it's like some known constant in the case of this data coming in as a flat variable here, like right at the beginning of the fragment shader, then GPUs are smart and they can look at all of these branches that I've got here, and they can, let's say the value is a circle fill. It can not take that branch and not take that branch and not take that branch. Like it'll intelligently know not to take any of these, only process that, skip right to the end of all of these, this like switch case that I've got here, and go all the way to the next thing it needs to be doing, which is handling a gradient type. So if the gradient type is, I think, 0, then yeah, it's solid. And then I've got a few other gradient types here, which Scream doesn't exactly use conic. does it use radial? Oh yeah, it's that shadow that you see at the bottom of this parameter here, that's a radial gradient. Wait, no, it's not. It's a drop shadow. And then I've also got inner shadow. So let's take a quick look at how I do that. Yeah, here we go. So this is a little bit more expensive, but you know, GPUs are pretty quick. So I've for now just like duplicated a lot of this code, and I do another SDF of that shape so I can like mask the colors that actually get rendered, and I'm able to create fake shadows that way. So this will compute some sort of distance between two colors. This T, yeah, here we go. The T value is like in the case of this shadow, it would be like some sort of gray to that's like a little bit opaque to you know, zero opacity. Here it would be interpolating between some gray to a transparent gray, and yeah, the shape comes from just doing the whole SDF a second time in the shader. So that's the central gimmick of this shader. The size of this shape, I think, is like 64 bytes. So if you just do like a little bit of maths and you consider that like an indexed, like index vertices, which is like a lot of OpenGL tutorials that you do, they'll take like two floats for like an X and Y value, which would be 4 bytes each. Then if you wanted to draw a rectangle, that'd be, you know, times another 4. You're looking at 32 bytes, but then you also need something like a color value. So you could pass the color value in these vertices, in your vertices structure. The color value, if you compress it, that'll be like, what is it, 2 times 4? So that's 2 floats that have now become, so we've got X and Y value there, we've got color value here. We're now looking at 48 bytes, but oh, what if you need a gradient? So now you need like 2 color values plus a position of like where another X and Y value of that gradient. If you're doing a linear gradient, you know, I believe DRM GUI, they sort of just like bake it into the vertices, like I think they bake the color into, it doesn't look great, but no, I'm not going to pull up the DRM GUI codebase. Anyways, things can pretty quickly get out of hand. If you wanted to have like really good linear gradients, you'd need 2 colors here packed. And then, yeah, beginning of that linear gradient, end of that linear gradient, XY values, 128, just for a simple shape. That's really just built to make a square. If you want to have rounded rectangles, well then now you need, let's say you wanted to do something, let's say you only wanted like one radius for each corner, then that's like another 4 bytes. If you want one for each corner, so you can do fancy shapes like that. Like the features just keep stacking up greater and greater. So that's like 4 corners right there, and now you've got 192 bytes just to draw one. Just to draw one damn shader. And you'll need to do plus 4 times, no, it'd be 6 times 2. So this is for the indexes for that triangle. You're now sitting at like 204 bytes to draw like a shape like that. It just quickly becomes too mad. Let's go back to like a solid color square. Like you're still looking at like 92 bytes. I've just removed all of these fancy features here. The amount of like this number grows to something absolutely silly if you use the classic index triangles trick for drawing shapes on the GPU. That was basically the only way people could do it, you know, back in like 2010, which is roundabout when some of these other libraries like NanoVG and Steerim GUI were written. They're using like a lot of these really old techniques. Today, old techniques are things like, well, they're newer, but they're still like 10 years old. You can do this vertex pooling trick where you can drastically reduce the amount of data that gets sent. And it's really easy to just like send over an enum. Also, yeah, simple tricks like text ID. So instead of like binding one texture at a time, you know, you just pass in another enum value, which, where am I using this? Here we go. Like that same, I guess, like condition folding thing that I was talking about with this SDFs types, you can do that with a texture as well. Load texture 1, 2, 3, 4, you know, I could have made this 8. I think a lot of fragment shaders cap out at like 16, I think might be. A lot of old hardware will have like a cap. And I think it's 16, so it's way bigger than what I've done, but I just didn't feel like writing that 16 times. So yeah, that's a neat trick for drawing most of what you need to do on your GUI. And if that shader doesn't suit your needs for anything, then you can just, you know, write your own shader to draw that last, you know, 5-10% of your interface that you need drawn. So GPU rendering. Yeah, like I wonder if I think I've got the old. Does that have? No, it doesn't. What are these? All right, never mind. I believe yeah, I can't prove it, but there's an older version of Scream. If you look back through Scream's commit history, where I was using NanoVG to draw that whole interface, and you know, I couldn't get this like nice, you know, less than 100 microseconds frame time. It was close to like half a millisecond when, you know, not streaming, when the computer's not under load. And yeah, I think the reason it was so slow was due to all of the draw calls that NanoVG makes. I think that's the biggest reason, with the second being the amount of data that needs to be uploaded, because NanoVG will tessellate something like a circle. So it's, you know, you're not just sending like enough bytes to draw a square. Instead, it makes this big fan of triangles. So all of those vertices, you know, which are how many bytes each? It could be something like 16 per point. Um, all need to be sent over, plus the indexes for all this stuff. It's a lot of triangles for the GPU to process, and they're pretty good at processing triangles, but the CPU is not as good at making them. So the CPU is pretty damn good at just like packing a little bit of data into like a small little struct of 64 bytes, and then shipping that. It's very good at that, and it's. I think the calculation was it improves GUI times by like something like 750%. It was like a massive boost. All right, last thing I want to talk about is immediate mode GUIs. So, I wrote my own. There's not exactly a whole lot of literature on how to make an immediate mode GUI. I haven't checked to see if Omar, the immediate mode GUI guys, ever blogged. If he does, they're probably good. But there's another guy, Ryan Fleury, crazy flinch spelling. Immediate mode GUI. He's got a really good article on designing immediate mode GUIs. There's another one, I think it's by our machinery. Um, immediate mode GUI blog. These guys took down their whole site, but this guy backed it up, and now you can still read it. I think you're not meant to, but hey, why not? Why not go do it? These guys talk about it. I'm actually still reading it. If you're interested in immediate mode GUIs, I think these two things would be a must read. This is definitely a must read. And all of the advice that this guy gives in here, I do not take. And I've got reasons for it. And maybe I'm wrong. But I think the way that this guy describes making immediate mode GUIs is fairly similar to what I understand to be the way DRM GUI works as well, which is the idea is every time you uh, have some procedure that might be like begin layout or draw button, you create this big tree of dependencies based on like function call order, and then maybe some other fancy rules that you've got under your hood, and it will start like linking up all of these structures, like parent and child, with certain properties on them, in the same way that CSS will have properties like this element's going to be this size. It's going to have like a font color of this if it's got text. And here might be its text field. It might have a border radius of this. Might be it might have stroked borders. All these sorts of things. That they're all just these structs with like a parent-child relationship living in this one big giant fat tree, and that's pretty nice. But I think, at least in audio plugin land, um, like the amount of times that you might want a fancy knob with all these with all this crazy skeuomorphism elements to it, like all these shadows, like see this rim that's like right on the edge of this parameter here. Like the amount of times that you're writing GUI code to make things look like this is it almost exists on every single project you work on. And so these CSS tips, well, I won't call it CSS, but these like CSS structs that live in this big tree that make applications that look like this, which do not have as much detail as this does. Like I think that advice doesn't really translate too well, because there's not well, I suppose you could just like add more and more. You could add an absolutely incredible amount of like detail, like drawing detail to each struct. There's probably a way to do it, um, but yeah, I didn't like it. Something that Fleury talks about here is he says like a lot of the complexity that exists in your immediate mode GUI framework will exist in the engine that you've got that will actually draw everything that ends up on the screen. And I didn't quite like all of this hidden complexity and engine management, since in the audio world, what we want is we want some sort of engine that we can bring from small project to small project, because we might be releasing 2-3 plugins a year or something like that. So if you've got like one big plugin that you work on over several years, and only one, then maybe it's worth it to have like a really pimped out engine. But in Scream's case, we've got like a couple of neat libraries that I can bring from project to project, quickly get something up and running. I've got a huge amount of flexibility when I need to start changing directions, and a lot of the complexity in the code that I write is isolated to that unit itself. It's not hidden away in this engine. So I just didn't like the sort of advice that he gave, which might be completely fine if you're writing different kinds of software. But for plugins, I think it's better to have this sort of complexity isolated um, in the actual feature that you're writing, which I do. I'll show you what our rendering code looks like. So let's look at how we make these parameters. What are we doing here? We're drawing the labels. Let's look at actually drawing these complicated things with all the shadows. Yes, this one here. So if we look here, we've just got a few constants that I've defined, like roundabout where I'm making the magic of this thing happen. I've got, like if I pull up Figma, like these are just values that I copy pasted from Figma. Same with that. Yeah, no, that's not the thing I'm doing. Come on, Figma. You better not make me log in. Yes, this one. These guys advertise themselves as local first, but here I am, probably making a network request to load the project that I know I haven't touched. Whatever. All right, well, trust me, there's some color values. In Figma, I've made a linear gradient, or like I've made some shadows here, and these are just values that I've copy pasted from there. And I do a whole bunch of drawing. Let's find where I handle the events. I must have scrolled past it. Most of this is, I think I've got a function called like handle, yeah, there it is. Handle parameter events. So, so here's the central idea. There is, oh, no, okay, yeah, the event comes from here. All right. So I've got a little module that I've made for myself. It's still a work in progress. I certainly don't claim that it's like the best GUI system ever. It's a bit of a novel one, but it's extremely flexible. The idea is I just say, hey, I've got a circle or a rectangle that I want to capture input events for. And it needs to have a little unique ID. I wish it didn't. But here I'm just using the parameter ID. And, you know, that's the size of either the circle, like with a point and a radius, or rectangle. And it's going to give me a bunch of flags that I can check to see, has the mouse entered or exited? Is the mouse currently over this widget? Are they clicking on it? Are they like, you know, holding it down? Maybe you've got a button that wants to animate like its position going down, or you want to create some sort of skeuomorphic thing, like change the shadows like at the top of the button to make it look like it's being pressed down. You can do stuff like that. Maybe you've got some other widget. Maybe you've got like an FL Studio, they've got this beat pattern grid, and if you like hold down your left mouse button, you're like filling in all of these grid beat values on their the name escapes me. Sequencer. I think it's a sequencer. And then if if you hold down and drag with your right mouse button, then you remove things. So You can do holding and dragging things. You can also capture that mouse wheel touchpad. That's like on Mac if you do those two finger scrolls. If you're dragging one widget, you can like place it on another widget, and the widget that got dragged can like get that event, and the widget that had another thing dropped on it also gets notified of these events. Um, so it's got a lot of features on it, and this is all just like checked at draw time. Um, there's some limitations to that, particularly when it comes to like trying to drag and drop files, and certainly to deal with keyboard events, which I'll talk about later. But for the most part, a lot of what happens in a GUI is just clicking on stuff, and that works pretty well. And an advantage of calculating all this sort of stuff at draw time and queuing all of these events that happen between frames is you drastically reduce the amount of CPU that your plugin uses when you're just moving this mouse around. Like if you have a crazy big tree structure where each of these little widgets is checking, oh, has this mouse been moved over me? Yes, no. Then if you're like moving your mouse around here, what may be happening is, or if you're moving your mouse from here to outside of the bounds to here, like in a retain mode like tree structure um, interface, like you're gonna have like probably some depth first search through all of these items in this tree, doing like bounds tests on all of these like cached positions um, of each of these widgets, which can be extremely CPU hungry. I think this one actually suffers from that a bit. I'm certainly not roasting these guys making this software. If I just start moving my mouse around here, you can notice that RadDBG ranks pretty high on its amount of CPU usage. In the grand scheme of things, it's not much, but you'd be hard pressed finding that much CPU ever coming from this piece of software, which is nice. Similarly, browsers. If I just open Task Manager and start like moving my mouse around here, like you can see Brave browser just shooting up as I'm moving my mouse around on this this website. HTML suffers from this problem as well, which means all these plugins that are using WebView, like not only is rendering an interface extremely expensive, depending on how you want to do that, you know, maybe you're using React or something. But even just moving around your mouse just starts to really take away a fair bit of system resources, which in the case of a, pardon me, in the case of a really busy plugin, no, in the case of a really busy DAW session, like you want as much audio as you can dedicated. You want as much CPU as you can dedicated to the audio threads. At the same time, you know, more and more these days, users do like having the flashy interface with all of the animations. So the challenge I think plugin developers need to try and overcome is how can we have both? How can we have the flashy animations that people like, and you know, it's just more fun. It's just more exciting, while also not robbing an incredible amount of resources from people. Well, I'll show you how I do this. There's one magic function called get events here. So if you remember, I had this. Oop, I think it's the wrong one. Yeah. So if I'm looking at these parameters, I do a quick like hit test to see is the mouse inside this circle. I actually do it many times. And let's look at this. So I've quickly, wait, I can't even remember what that did. was a year ago that I wrote this. uh, okay, that's the XY position of the mouse at a certain time. So when like the operating system sends, hey, this left mouse button is now down, I just like, I save the position here of the mouse. Things like you know, if you want to respond to when like someone shift clicks or like control clicks or something, or they're dragging their mouse with like the shift button. Okay, so what I'll do is if I drag this here and I hold down the shift key and control key, I've written things such that when these drag move, drag value. Oh yeah, okay, I actually made this a library function. If the control key or the shift key is held, like reduce the amount that the parameter is moved by like 90%. And if both the shift and the control key are held down, then it's like, you know, only 1%. So if you want to do like really fine-tuned parameter changes, yeah, hold down shift and control, or shift and command on Mac. Like this is data that's just like cleared every single frame, so it captures like these drag events, but that are messages sent to the window between frames, and just looks at, yeah, their modifiers. Which does mean that this function gets hammered every single frame. So like each thing, each widget that you can interact with is calling this function here, and it's doing at least 3 hit tests, which, you know, are pretty quick for a computer to do. So like that's a widget, that's a widget, that's a widget, 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 widget. Another 2, 4, 6, 8, 10. That's another one. This I do as a strip. I think I do that one. I might do that as a strip as well. That's a widget. These are widgets. This is like several widgets. Like each point is a widget. Widget, widget, widget. Like it can get absolutely hammered. But what's nice about doing that is you don't get any performance spikes. Like if you're moving your code around on this web page, and like I'm not roasting this web page, like literally any web page on the internet, like you get all these CPU spikes, which in audio programming, CPU spikes are bad. You want like a predictable amount of CPU being consumed, and this approach to checking for capturing like mouse events, I think the amount of CPU burn is it's already like pretty minimal, but it's also constant for the most part. The things that cause CPU usage to spike is like resizing the window, which I'm not sure anyone's got like a great solution to that. It's like always expensive. So yeah, and like the way this works, it's kind of like the simplest thing you can imagine. Like, does the if the hit tests have passed and there are no recorded like if the mouse is, if the left mouse button is not currently down, and we're hovering over a widget, then, you know, that widget, like we'll save that ID of that widget right here, such that for as long as this you know, left mouse button being held down, when it starts to be moved over like other widgets, or just whenever it's moved around, like we send like a drag event, which would be down here. Um, but oh, and like if it's entered the bounds of a widget and it's currently not over the bounds of anything else, then we'll send like a mouse enter event, and we do other tricks to detect like a mouse exit event based on where it was in the previous frame, and also like how many things we've looked at um, this frame. The call order matters, so it in this system it come like it's written as like um, we collect events from we've got a priority for mouse ownership that goes front to back. Um, I can't remember why I did that because I wrote it a year ago, rather than back to front. Um, I think that's to do with yeah. I think you need to do that because I'm not even sure if I can explain why. I might not be smart enough. Yeah, so like if we were to imagine that there's absolutely nothing on the screen except for this one knob right here. Actually, two knobs right here. And if you want to try and remove like one frame of latency, um, then I think it's more useful to like as soon as you drag your mouse into the bounds of this plugin, if it can on that frame, like as soon as it's detected that you're over um, that this knob rather than this knob, and you're checking to see if it's like within the frame, if you're checking to see if it's over this knob first before checking that one, um, then you can do things like change the mouse cursor from plane one to this like resize up and down cursor. Um, you can respond to that event, that frame. You can fire that one off that frame. Um, Similarly, even though this is drawn second, it looks okay. Was it over any other widget um, in the previous frame or this frame? No. Okay. So we can now give mouse ownership to this widget right here. So that's the idea, and I think that's why it needs to be like front to back rather than back to front, which is a little bit annoying when it comes to rendering. Um, I'd say that's the biggest weakness of this strategy, despite all of the strengths um, of writing things this way. Like the ability to, like, I'll just show you how I use this again. Yeah, like this whole widget, I can just say like get events here. Um, oh, I wonder if maybe this is a better example. What am I drawing here? I think I'm drawing these things right here. Yeah, the modifiers. Um, so I can get the events like this. I can respond to all of these like mouse events right here, and then I can immediately draw it. And if I want, let's just put this back into hot reloading mode. Oh, I think that's debug only. Then let's say, for example, I didn't like doing any of this. Something I could do is, shush. Now, like all of my rendering for this code, all of the ability to capture mouse events, like all of this has just been been removed because like everything relating to this widget is all isolated in one spot. Um, so to this isn't really like a criticism, but this is like a, I suppose, a weakness of, I think, the sort of um, like tree based design, the big fat struct design that you hear guys like this talk about, like DRM GUI, um, like that whole approach. Nuclear is the same. Like that's fine for writing like tables and lists and stuff like this, like interfaces that look like this. But it's not really great where almost every single element, not every, but a lot of elements that are on your screen all have their own unique custom look. And you need like as much control over what every single thing looks like as possible. And you don't want to just like keep stuffing more and more features in fat structs and having to look up, oh, what features have I got in my structs again? Like you don't want any of that. No switching. You just say draw text, draw circle, draw arc. You know, draw text. That's this thing right here. Draw circle. What's that? Like a stroked circle. That's, you know, this round thing there, and then draw an arc. That's the value of this thing that done. You know. No looking at what are the features that my fat struct supports, any of that. And if you need to completely change the design, but like still have the same mouse capture behavior, then bam, you just say like, I don't know, draw rectangle or something like that. And, you know, do that. I think it's completely fine writing interfaces like this. Ryan's got some criticisms of this way of writing interfaces in here, which I think are completely valid for writing some software, and then I think it's not great for plugins because plugin developers are making so many plugins that all look different. And we're making things that are irregular shapes. It's not just like rectangles everywhere and borders. It's like shadows everywhere and, you know, these fancy arcs. Another thing is like how, oh, no, actually, forget that tangent. All right, so that's immediate mode GUIs. Oh yeah, and also like, why use an immediate mode GUI? So like a real pain in the neck. That if you're using a framework like Juice, like iPlug, like DPF, like the Qt framework, um, anything with these like parent-child relationships, um, like DRM GUI and the sorts of um, designs of immediate mode GUIs that these guys talk about. Like they'll have an interface that's immediate mode, but under the hood, it's like still the same parent-child relationship way of writing. Pardon me. Interfaces. So like it's really cumbersome doing things the classic like you know, you've got a class that inherits from an object, and in the constructor of that class, like you might have a few children on there and you need to manually link them up. So you need to say like add, you know, this child property, which is like some child widget. It could be, for example, like maybe there's a root widget, which is this whole thing here. This is a child widget right here that needs to be manually appended to the parents like list of children, which might be like a vector or something like that. Then you know, so does that, and all these other things. It's like a lot of linking up. And if you, let's say, like a moment ago, I just like commented out some code and removed all of this. Let's say you don't like the design of this, you don't like where it's placed. You might need to completely rethink how your plugin's handling modulation. Maybe you want to have some system where you could have many more modulation options here. You could have 8 different LFOs rather than 2. Like you can't. You might not want to put 8 little circles to drag here, you might want to have some dynamic little dot that appears up here with a number 8 on it to let the users know that they're changing the modulation amount um, for number 8. You know, like Vital will do these sorts of things. Okay, it puts it down there, and as you hover over it, it'll tell you you're looking at envelope number 1. And Vital needs to do that because they've got so many damn modulation options. Well, gosh, darn it! Now you need to like completely rewrite all of this code um, to handle all of these different features. The cost of like undoing this is extreme because like you might have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different widgets that all live on the parent, or maybe you know you've got some other class where this is some object and that is a child, and then these two things are a child of some objects, which is like a I don't know, like a linear slider class or something like that, or like a main parameter class or something like that, main rotary parameter class. Like you just have to unhook all of this stuff. Not only um, uh, like the add to parent, you know, maybe remove from parent if it's like some dynamic thing, like Vital's got. Um, uh, the layout of the widget, like maybe you've, like in the case of Vital again, like if we move a couple of these things on here, look at that. Like they've intelligently you know, shuffled places. Um, so there's like all of this additional code that might exist on the parent as you're um, moving these things, uh, moving these modulation sources, like and dropping it onto the parent. It might have all of these functions that expects to change data from um, that might live on this like this child object, um, which is yeah, like a real pain to deal with. Instead, if you've got like that entire feature just like isolated in its scope to a small amount of code that you've got here, and maybe you know some of them are a bit more complicated. There could be much more complicated like layout logic. There could be much more complicated drawing logic. Like look at all of this. So this is the parameters here. If I fold all of this down, maybe just this whole case. How many lines of code is this? Almost 150. But you know what? Like while this is running, I can just go doop de doop de doop de doop de doo, comment, bam. Now it doesn't exist anymore. And if I wanted to put something completely different there, I could. And it's all safe to just like keep going. And yeah, like you can safely just remove data, remove code from your code base like that, and not have to be jumping through a bajillion files, scrolling up and down, finding little bits of that widget in all spread across all of these different functions. Because for the most part, the state of your program, and here's the important takeaway: like the state of your program lives on the stack rather than on the heap in some big data structure, or in like some cached tree from last frame or whatnot. Like you can just forget about all of that. The only data that this whole system really caches is like a little ID, which exists on this like immediate mode GUI library. Like here's the retained data. It doesn't grow as like there's more items that appear on your screen. It only grows as you like call more functions. it only grows as like source code grows, and um, yeah, so that's nice. It also means that you're not dealing with all these nasty pointers trying to like link up trees of components or objects, and having to like carefully like scale up and down these things. Um, which, you know, at the end of the day, it's not that hard to like correctly scale up and down a tree. It can, I mean, it's pretty like, I suspect that the reason just moving your cursor around a web page is so slow is because you're just absolutely slamming the cache of filled with, you know, either well written fat structs like what this guy might be writing, or really sloppy fat structs which come from like years and years of legacy HTML and CSS standards um, in the browser. Um, yeah, so pretty minimal on state, less problems, less pointers, less crashes, um, and uh, better. You also improve your ability to like change course. So you know you could be, let's say, 50% way through some project, and then maybe you've got like a minimum viable product that you send out to some people that want to test your software, and you know they've got some big feedback or maybe feature suggestions for your plugin that require you to actually make some serious changes, such as maybe it's like the way you handle modulation. You might have a great idea. Oh, here's a great way to do modulation. You actually give it to a user, they hate it. They've got a way better idea that they suggest that you take. And like how quickly can you implement that idea? Like, is it an absolute pain to untangle um like all of these you know, classes and parents and children relationships? If that's a big pain to untangle, then you might end up, unfortunately, going back to that um, uh, beta tester and saying, "Oh, sorry, this is like too hard. It would take too long to do because basically we've dug ourselves a big hole since the approach to writing a GUI that, you know, the framework designer has taken is just too much of a pain in the neck to deal with. But if you've got a immediate mode system like this, where you can very safely just like delete all this code and like be on your merry way, then you literally just like comment some stuff out and then go ahead and make that new feature, which is really nice. And I hope over time the value of that approach um, can save you time in the long run, and can mean that you actually test a whole bunch of ideas that you may have never tried otherwise because it was just like too slow, too cumbersome. Um, and hopefully it can reduce stress as well, because all of this complexity just drains your spirit. Um, it you know can reduce motivation that you've got, and I think trying new ideas actually invigorates you. It's the sort of thing that makes you want to jump out of bed, you know, at like 6 in the morning or something like that. Turn the computer on and just start working on this great new idea that you've got, because you know just how easy it is to actually implement that idea in your, you know, neat novel framework. Yeah, good luck trying to do that in these really cumbersome, clunky frameworks that require you to like first add a bit of state in some header file, which is probably going to trigger like a full rebuild of like your your whole code base. Who knows? That could be like 10 seconds, 15 seconds, just to like you know, make that one change. Then you got to write um, like add child to parent within the constructor of that function. So you got to go find that constructor, and then maybe there's a few other settings that you need to pass in there. Maybe that child that you added to that parent needs to have a few things passed to its constructor. Then you got to go to like the layout method. So you got to scroll down and find that, and then like put in some. My God, like you've probably already forgotten this great idea for the feature that you wanted to add. Like in the time that it's taken to just like remember to follow all these steps to get some stuff on the screen. It's an absolute nightmare, and I think approaches like this are the future. I think the performance of just like actually calculating the layout for all this sort of stuff, and even like fairly expensive stuff like text layout on modern computers and even old computers, it can just easily do all this layout code every single frame. And um, like I mean, if you've made it to this far in the video, I'll probably be wrapping up this stream any second now. Like you've seen just how much CPU this thing uses. It's barely any. So yeah, performance is great. The I reckon the thing that usually causes immediate mode GUIs to be so slow and CPU intensive is actually the rendering. So if I put pretty good effort into having really big batches with my draw calls, such that I can just like save tons on performance. And with this whole like imgui get events tricks that I've done, if I actually just like comment all of this out and just say return 0, such that I'm not doing all of this, you know, looking at all of these, doing all these conditional statements, like it just doesn't even affect the CPU usage of the program. Like I can't notice any difference. So even though it looks like a lot of code, how much code is it? Over 200 lines. And it just gets like slammed every single frame. Like it doesn't even register as something that consumes performance. Who knows how that'll go on things where, maybe you've got 1,000 small objects on the screen. Maybe then it starts to be like a few microseconds. Who knows? Which is not much. A few microseconds is not much. Even if it was 10 microseconds, that's not much. So yeah, I think this is a pretty good system. If you're a nerd and you're into building, your own frameworks, definitely take a look at this, and by all means fork it, and or take on some of the concepts and try and improve it. And if you've got any suggestions of things that could be improved, always interested to hear your thoughts and improve my own code. Yeah, cool. All right, I think this stream's gone on for long enough. Yeah, gosh, it's 1:30 where I am. I'm gonna go have some lunch. Well, thank you very much. Oh, there's actually someone viewing, one concurrent viewer. Oh, what's up, man? Are you ready? Oh, yeah, sorry. I never bothered checking the. I don't think he's checked the chat once. Knows why it won't notify him. Whatever. Cool to see it regardless. Well, I'm glad you had fun. This is my first ever stream. I'm a total noob to this, but this is a good test run. No one's complained about audio, so I guess I did that right. Cool. Well, yeah, thanks for watching, and goodbye. See you on the next one, if I do one.